could easily be throwing an entire tank of fuel straight into the garbage every single month. You aren't driving any harder. You haven't changed your daily commute. You aren't towing a heavy trailer. You're just silently bleeding money at the gas pump because of a totally invisible choice sitting right in your driveway. And the absolute craziest part is that 99% of drivers will never even think to physically check it. Guys will literally spend entire weekends trying to chase down a fuel economy problem. They will aggressively rip their intake manifolds off to clean their fuel injectors. They will spend hundreds of dollars replacing perfectly good oxygen sensors. They will dump heavy chemical cleaners into their gas tank hoping for a magical fix. They rebuild the top end of the motor, they do a massive tune-up, and they get back on the highway only to realize they are still getting totally terrible mileage. They instantly blame the engine. They think the manufacturer built a gas-guzzling piece of junk. But the problem isn't the engine. The heavy metal block is doing exactly what it was engineered to do. The actual problem is sitting directly underneath the chassis. It is the only physical part of your entire vehicle that actually touches the asphalt. Today, we are completely tearing apart the massive fuel economy lie bolted to your wheels. We are going to break down exactly which specific types of tires are actively sabotaging your gas mileage and forcing your engine to work significantly harder than it physically has to. We are going to look directly at how to identify an incredibly inefficient tire on the rack before you ever hand over your credit card. We are going to expose the exact chemical compounds that actually save you money at the pump. And by the time we finish, I am going to show you one incredibly simple, totally free mistake that completely destroys the efficiency of even the absolute most expensive, top-tier tires on the market. Let's get straight into the raw physics of how your car actually moves down the road, because this is exactly where the entire misunderstanding starts. Most drivers think fuel economy is purely a calculation of how efficiently the engine burns liquid gasoline. That is only half the equation. Fuel economy is entirely dictated by the total amount of physical energy required to keep thousands of pounds of heavy steel moving forward against the natural forces of gravity and friction. And the absolute biggest parasite violently draining that forward momentum is a physical force called rolling resistance. Every single time your tire makes contact with the road, it physically flattens out. It deforms under the massive weight of the chassis. As the wheel continues to spin, that flat spot rolls forward, and the heavy rubber has to snap aggressively back into its original round shape. This constant, totally violent cycle of flattening out and snapping back happens thousands of times every single minute you are driving down the interstate. And here is the brutal reality of physics. Bending thick, heavy rubber requires massive amounts of raw energy. The more that tire physically deforms against the hot asphalt, the more energy is instantly lost. Think about it like this. Imagine you are standing on a perfectly smooth concrete floor. I hand you a heavy, totally solid bowling ball and tell you to roll it across the room. You barely have to push it. It glides effortlessly because the hard outer shell completely refuses to deform. It possesses incredibly low rolling resistance. Now, I hand you a heavy rubber medicine ball that is slightly deflated. If you want that soft, squishy ball to roll across the exact same concrete floor, you have to physically push it the entire way. You have to actively fight the heavy rubber as it constantly flattens out against the ground. The physical effort you exert to keep that squishy ball moving is the exact same mechanical effort your engine has to exert to keep a highly inefficient tire moving down the highway. That wasted energy doesn't just disappear into thin air. It is violently converted into physical heat and mechanical friction. And to generate that wasted energy, your engine has to physically burn significantly more gasoline. This brings us directly to the actual chemical composition of the rubber sitting on your wheels right now. The chemical makeup of a tire entirely dictates how much fuel you are going to burn on your way to work. When you buy cheap, low-tier tires, the manufacturers are heavily cutting costs on the internal chemical compounds. They use basic, highly unstable, soft rubber blends. When these cheap compounds roll down the highway, they suffer from a massive physical flaw called hysteresis. Hysteresis is a strict mechanical engineering term for the specific amount of energy that is permanently lost when a physical material bends and then returns to its original shape. Cheap rubber has incredibly high hysteresis. It literally fights itself. As the cheap tire spins at 70 miles an hour, the internal rubber molecules violently rub against each other. This creates massive internal friction. The tire physically heats up to totally unnecessary temperatures. All of that raw heat radiating off the cheap rubber is literally your hard-earned gasoline evaporating directly into the atmosphere. The engine has to actively fight the tire just to maintain basic cruising speed. Now compare that to a highly engineered, premium, fuel-efficient tire. Top-tier manufacturers completely abandoned cheap, heavy carbon black rubber compounds years ago. They heavily infuse the tread with advanced, high-density silica and synthetic hybrid polymers. These highly advanced chemical structures are physically rigid exactly where they need to be, but totally flexible in the exact right spots. They massively reduce internal friction. A highly advanced silica-infused tire physically glides over the pavement with heavily reduced rolling resistance. The engine doesn't have to constantly fight to overcome the mechanical drag. The throttle stays incredibly light. The fuel injectors don't have to violently spray as much raw gas into the combustion chamber just to maintain 65 miles an hour. It is a completely invisible, highly effective mechanical advantage. Before we get deep into the highly specific types of tread patterns that are actively destroying your fuel economy and the massive mistake SUV guys make every single day, let me know exactly where you are watching from today. Drop a quick comment down below with your city or state. I always read through them, because the specific climate and the exact condition of the roads you drive on completely change the physical stress your tires are actively taking. A guy driving his commuter car on perfectly smooth, flat highways in Florida is dealing with a completely different mechanical reality than a guy navigating steep, heavily broken mountain roads in Colorado. The environment entirely dictates the wear and the efficiency. And if you actually appreciate getting the raw, unfiltered engineering truth about how your vehicle actually operates instead of falling for the standard tire shop sales pitch, do me a massive favor and hit that like button and make sure you are subscribed to the channel. It tells me you guys want real garage knowledge and it pushes me to keep pulling the curtain back on the invisible stuff that heavily drains your wallet. Because I see this specific drain happening in my repair bay constantly. I had a guy bring in a late model, naturally aspirated Japanese sedan a few weeks ago. The car was incredibly well kept. The paint was pristine, the interior looked completely brand new, and the engine bay was spotless. He handed me the keys and told me the car was suddenly getting absolutely terrible gas mileage. He used to easily hit 35 miles to the gallon on the highway, and over the last 2 months it had aggressively dropped down to 26. He was completely convinced the engine was silently failing. He aggressively begged me to run a massive compression test, physically check the catalytic converter, and completely tear the fuel system apart to find the hidden leak. He was totally ready to drop $2,000 on a massive diagnostic and repair bill. I put the car on the heavy 2-post lift. I didn't even plug the computer scanner into the dashboard. I didn't pull a single spark plug out of the cylinder head. I simply walked over to the front driver's side wheel and ran my hand heavily over the rubber tread. I looked at the exact brand, the specific tread blocks, and the heavy load rating stamped on the totally unfamiliar sidewall. I knew exactly why his engine was violently burning through an extra tank of gas every single month. He had made a totally innocent, seemingly logical decision a few months prior that completely destroyed the mechanical efficiency of his entire powertrain. And it is the exact same, totally invisible mistake millions of drivers are actively making right now when they pull their cars into a discount tire shop. I looked straight at his front wheel, and the problem was completely obvious. He was driving a standard front-wheel drive commuter crossover, but he had just bolted on a brand new set of incredibly aggressive, thick-tread, all-terrain tires. I asked him if he had suddenly started taking his daily commuter car out to the muddy trails on the weekends. He looked at me totally confused and said no. He just liked the way they looked. He wanted that rugged, aggressive off-road aesthetic. He thought it made his basic crossover look like a tough Ford F4. He totally got the look he wanted, but he was actively paying a massive recurring subscription fee at the gas pump for it. You have to completely understand what an all-terrain or mud-terrain tire physically is. Those massive, chunky blocks of heavy rubber are engineered for one specific purpose: to violently dig into deep mud, loose gravel, and soft dirt. They are built to grab raw earth and physically throw it backwards so the truck can move forwards. But when you take that exact same massive, blocky tread pattern and you roll it down a perfectly smooth, flat suburban highway, it turns into an absolute nightmare for your engine block. First off, you have a massive aerodynamic problem. The air physically gets trapped between those giant, aggressive rubber blocks as the tire spins. It creates totally unnecessary air turbulence. If you have ever driven a truck with heavy off-road tires, you know exactly what I am talking about. You hear that loud, aggressive humming noise echoing straight through the floorboards when you hit 60 miles an hour. That heavy humming noise isn't just an annoyance. That is the exact auditory sound of your gasoline evaporating. That noise is raw acoustic energy, and your engine had to burn extra fuel to physically generate it. But the aerodynamic drag isn't even the worst part. The absolute biggest killer is the physical weight of the rubber. Aggressive tires are incredibly heavy. They have thickly reinforced sidewalls and massive amounts of extra compound molded into the tread. Most drivers totally fail to understand the massive mechanical difference between the weight sitting inside your trunk and the weight bolted directly to your wheel hubs. Engineers call this unsprung weight or rotational mass. If you throw a 50-pound bag of sand into your trunk, your engine barely notices it. It is dead weight. But if you add just 10 extra pounds of heavy rubber to each of your 4 tires, the physical math totally changes. Your engine doesn't just have to carry that extra 40 pounds forward. It has to physically grab that heavy rubber and forcefully spin it from a dead stop against the raw friction of the asphalt. Adding 10 pounds of heavy rotational mass to a wheel puts the exact same mechanical strain on your powertrain as dumping 100 pounds of dead weight directly into your back seat. Your transmission has to shift much later. Your RPMs hang significantly higher. You are actively forcing the heavy metal under your hood to fight a massive, totally unnecessary physical battle every single time the traffic light turns green. And your fuel economy absolutely tanks as a direct result. Let me know exactly what you guys are running right now. Have you ever bought a set of heavily aggressive tires purely for the look and instantly regretted it the second you looked at your gas gauge? Drop a comment below. I want to see how many of you fell into this exact same trap, because the tire shops absolutely love selling these expensive upgrades, but they conveniently forget to mention the massive drop in gas mileage. Now, let's step away from the off-road guys for a second, because there is an entirely different trap that strictly street driving guys fall into every single day. It is the cheap tire trap. You walk into a big discount tire chain. They show you a name-brand tire for $200 a corner. Then, the guy behind the counter points to a completely unknown, unbranded tire imported from overseas sitting right next to it. He tells you it is only $80 a tire. He promises it has the exact same mileage warranty. He totally convinces you that you are outsmarting the system by saving nearly $500 on a full set. You aren't outsmarting anybody. You are buying a highly inconsistent, totally inferior product that is going to aggressively punish your wallet in complete silence. To build a tire that incredibly cheap, the manufacturer has to heavily cut corners on the internal construction. Inside a modern tire, beneath the rubber you can actually see, there is a highly complex structure of woven steel belts, nylon cap plies, and heavy fabric cords. Quality manufacturers build this internal skeleton with extreme precision. Cheap manufacturers do not. Their internal steel belts frequently overlap. The heavy rubber compound is not distributed perfectly evenly across the entire circumference of the tire. Out of the mold, the tire is physically unbalanced. When the shop bolts that cheap, poorly constructed tire onto your car, They have to stick a massive amount of heavy lead wheel weights onto the rim just to get it to stop violently shaking on the balancer machine. But even with the weights, the physical casing of the tire is still highly inconsistent. As you drive down the road, that tire creates completely invisible micro-vibrations. The rubber doesn't roll perfectly smooth, it aggressively jitters against the pavement. Remember the raw physics we talked about earlier? Every single one of those microscopic vibrations is physical energy violently escaping the system. I had a guy doing rideshare full-time down in Florida. He was putting crazy mileage on his hybrid sedan, sometimes 3,000 miles a month. He was totally obsessed with keeping his running costs low, so he bought the absolute cheapest bargain bin tires he could physically find online. He saved maybe $200 up front. But within exactly 2 months, he came into my shop highly frustrated. His incredibly efficient hybrid was suddenly getting 5 miles less per gallon. He was having to fill up his gas tank an extra time every single week. When you do the physical math on how much he was driving, that cheap set of tires was actively costing him over $50 a month in entirely wasted gasoline. Over the absolute lifespan of those tires, he was going to lose almost $1,000 at the pump just because he tried to save $200 on the purchase price. The cheap rubber was totally rejecting the road, actively fighting the electric motor, and completely destroying the built-in efficiency of his entire car. And this leads entirely into another massive mistake I see SUV and light truck guys making constantly. It is the total confusion between passenger tires and heavy commercial load tires. You look at the sidewall of a tire, and right before the size numbers you will see a letter. It will usually say P, which stands for passenger, or LT, which stands for light truck. A P-metric tire is engineered specifically for standard, comfortable street driving. It has thinner, highly flexible sidewalls. It is physically lighter. It rolls incredibly easily. An LT tire is an entirely different beast. It is highly engineered to carry massive amounts of heavy cargo or tow heavy steel trailers. To physically survive that extreme load, the manufacturer wraps the entire tire in extra heavy layers of thick steel ply. The sidewalls are incredibly stiff. The entire tire physically weighs a massive amount more than the exact same size P-metric tire. Guys buy a perfectly nice, lightweight SUV that is engineered totally for driving the kids to school and commuting to the office. The factory puts highly efficient P-metric tires on it. But when it comes time to replace them, the owner tells the tire shop he wants something heavier, something more durable. He asks them to bolt on a set of LT-rated heavy load tires. He drives off the lot and his car feels totally dead. The steering is heavy and unresponsive. The suspension violently crashes over simple potholes because the stiff LT sidewalls completely refuse to flex and absorb the impact. And worst of all, his gas mileage totally falls off a cliff. He essentially just bolted heavy commercial work boots onto a lightweight track athlete and expected them to run the exact same sprint time. The engine has to physically work twice as hard to turn the massive commercial-grade steel belts. You have to actively match the physical engineering of the rubber to the exact physical reality of how you actually drive the machine. Putting a heavy 10-ply load tire on an SUV that never physically tows anything is an incredibly expensive, totally unnecessary way to murder your fuel economy. But even if you totally avoid the cheap brands, ignore the aggressive off-road blocks, and buy the absolute best, highly rated, fuel-efficient tires on the market, you can still totally destroy your gas mileage if you are driving around with one specific mechanical flaw. Because even the best rubber in the world turns into a massive gas-guzzling drag if the wheels are actively fighting each other. When you hit a massive pothole on the highway, your suspension physically shifts. The heavy metal components violently absorb the impact, and the microscopic geometry of your entire front end is instantly altered. Your wheels totally lose their perfect factory alignment. They start pointing slightly inward or slightly outward. Mechanics call this the toe angle, and it is an absolute silent assassin for your fuel economy. If your front tires are heavily toeing in, they are no longer rolling straight down the highway. They are physically trying to drive towards the exact center of the car, but the heavy metal tie rods are violently holding them in place. You are literally dragging your rubber sideways across the raw asphalt for thousands of miles. Imagine a guy trying to walk rapidly down the street with his feet heavily pointed entirely inward like a duck. It is totally exhausting. That is exactly what you are forcing your car to do. The engine has to generate massive amounts of extra torque simply to overcome that heavy lateral drag. You will completely shave the inside edge of your tread down to the raw steel cords in a few short months, and your gas mileage will absolutely plummet because the vehicle is constantly fighting its own forward momentum. But there is a mistake that is incredibly worse, and it requires absolutely zero mechanical failure to happen. It is a mistake that completely ruins the efficiency of even the absolute most expensive, top-tier rubber on the market. You can go out right now, spend $1,200 on a highly engineered, silica-infused set of low-rolling resistance tires. You can have them perfectly road force balanced and precisely laser aligned. And you can still totally destroy their physical efficiency by ignoring the single most critical element holding the entire heavy metal chassis off the ground: the raw air pressure. Most guys look at a tire and entirely misunderstand what it does. The heavy black rubber does not physically support the weight of your car. The highly compressed air trapped inside the tire is the actual mechanical component doing the heavy lifting. The rubber is basically just a highly flexible, durable envelope, totally designed to hold that invisible air precisely in place. When you let your tire pressure drop even a few pounds below the factory specification, the physical structural integrity of that envelope completely collapses. The tire physically sags. The contact patch, the exact amount of heavy rubber physically touching the asphalt, massively expands outward, and when that contact patch gets wider, the raw mechanical friction violently skyrockets. We go right back to the raw physics of hysteresis. The soft, heavily underinflated sidewall has to aggressively bend and flex significantly further with every single rotation. The internal heat heavily builds up. The engine suddenly feels incredibly sluggish when you hit the gas pedal to merge into heavy traffic, because it is physically dragging 4 totally soft, heavily sagging rubber balloons down the interstate. You are forcing the engine to constantly push a piece of rubber uphill, and this leads directly to the absolute biggest lie sitting perfectly illuminated on your dashboard right now. Most drivers blindly rely on the little orange low tire pressure light to tell them when to grab an air hose. They assume if the TPMS light is completely dark, the pressure inside the tire is perfectly fine. That is a massive, highly expensive misunderstanding of exactly how your digital computer actually works. That TPMS light is a heavy safety warning designed to keep you from totally blowing a tire out at 80 miles an hour. It is not a highly sensitive fuel economy gauge. Federal regulations dictate that the computer doesn't even trigger that bright orange warning light until the tire has physically lost 25% of its totally recommended air pressure. Think about the absolute raw math on that. If the heavy sticker inside your driver's door demands 35 psi, your tire can be sitting completely flat at 26 psi. The dashboard stays totally dark. You feel completely confident driving down the road. But at 26 psi, the rolling resistance has already aggressively spiked to massive levels. The engine is actively burning noticeably more fuel, the rubber is aggressively wearing out on the heavy outside edges, and you are totally oblivious to the invisible leak in your wallet purely because the computer hasn't started screaming at you yet. This exact scenario gets radically worse when the ambient climate physically changes. Cold air is heavily dense. When the temperature totally drops in the freezing dead of winter, the compressed air inside your tire physically shrinks. You can easily lose 3 or 4 raw psi overnight simply from a heavy cold snap. Guys wake up, jump in their freezing cold cars, and drive an hour to work totally unaware that they are instantly losing 2 or 3 miles to the gallon. They instantly blame the heavy winter blend gasoline at the pump, or they wrongly assume the cold engine block is just naturally burning extra fuel. The heavy metal engine is perfectly fine. The tires are just physically flat. I had a customer bring a mid-sized domestic SUV into my bay a while back. He was totally fed up and ready to trade the vehicle in. He told me the car felt incredibly heavy, almost like he was permanently towing an invisible trailer. He was aggressively burning through fuel. The crazy part was he had just spent $800 on a brand new set of premium touring tires 2 weeks prior, fully expecting his gas mileage to shoot straight up. It didn't. It actually got noticeably worse. I didn't plug a computer into his OBD port. I grabbed my heavy digital pressure gauge and walked around his chassis. The factory door sticker strictly called for 36 psi. His front left wheel was sitting at 22. His right rear was at 25. The discount tire shop that rapidly installed his expensive new rubber was totally in a rush, completely failed to physically check the final pressures, and just slapped the wheels onto the hubs. We didn't change a single mechanical part. I literally just hooked a heavy air hose up, brought all 4 corners perfectly up to 36 psi, and handed him the keys back. He called me the very next afternoon, totally blown away. The heavy, totally dragging sensation was entirely gone. The steering felt incredibly light, and his fuel economy instantly jumped back up by nearly 4 miles to the gallon. He almost sold a perfectly good piece of machinery purely because of a lack of highly compressed air. If you are sitting there right now realizing you haven't physically checked your air pressure with a real mechanical hand gauge since your last oil change, you need to execute a complete efficiency reset on your specific setup. Do not just blindly run out and buy a massive new set of expensive eco tires. Work directly with the physical machinery you already own. First, physically check the cold air pressure early in the morning before the car even moves. Inflate it exactly to the heavy sticker inside the driver's door jamb. Never inflate it to the massive maximum pressure number stamped on the sidewall of the tire itself. Second, run your bare hand aggressively across the raw surface of your front tires. If you feel heavy, uneven cupping, or if the inside edge is totally smooth while the outside edge still has deep tread blocks, your mechanical alignment is violently out of spec. You absolutely have to fix the heavy mechanical drag before you even think about upgrading the rubber. Now, I have to be completely straight with you, because prioritizing raw fuel economy is not a blanket rule for every single driver out on the road. There are highly specific situations where buying a hard, fuel-efficient tire is a totally dangerous mechanical mistake. If you live down a heavy dirt road that totally turns into deep, slick mud every time it rains, you absolutely need an aggressive tread to physically dig into the earth. If you drive a heavy, rear-wheel drive sports car pushing 500 raw horsepower, you completely ignore fuel economy and you buy the absolute stickiest, softest summer compound you can physically afford. Because in those heavy performance situations, absolute physical traction keeps you out of the concrete median. In those highly specific environments, heavy grip and absolute mechanical safety violently override a few extra miles at the gas pump. You actively accept the significantly higher fuel bill as the exact physical cost of operating that specific machine. But for the 90% of you guys just trying to get a daily commuter car back and forth to the office without totally emptying your bank account, you have to completely shift your mechanical perspective. The average guy blindly obsesses over raw horsepower and heavy engine displacement. He totally ignores mechanical efficiency. You do not make a car get better gas mileage simply by forcing the engine to run perfectly. You make it highly efficient by physically preventing the vehicle from actively wasting the energy the engine is already producing. Your tire is the absolute frontline soldier in that highly invisible fight. When you bolt heavy, cheap, totally underinflated rubber to your wheel hubs, you're basically driving around town with your parking brake heavily engaged. You are actively fighting the natural physical momentum of the machine. Choosing the exact right, highly engineered silica tire and keeping it perfectly inflated is the exact physical difference between violently fighting the heavy asphalt and letting the metal totally glide over it. If this breakdown completely changed the exact way you look at the heavy black rubber sitting under your car right now, do me a massive favor and hit that subscribe button. Drop a quick comment down below and tell me exactly what specific tires you are running on your daily driver right now. Are you riding on heavy, gas-guzzling all-terrains, or did you actively buy a set of high-end touring tires? I read through every single one, and I want to see exactly how much extra fuel you guys are actively burning. Stop blindly blaming your engine for a totally invisible suspension problem. Actively check your cold tire pressures in the morning, and I will see you in the next one.